Bill, I think we can get started.
Yeah. Yeah, let's get rolling here. Oh boy. Okay, good. All right. So I'm Bill. I'm obviously in my office. And we're going to talk about a couple of things and then do a little bit of demo stuff. And I won't take like a whole huge amount of time. Since it's such a small group, we can sit and chit chat and do questions, which is nice. I've done a few of these that were big, and we had to like manage the questions and stuff. So that was harder. But with just 5 of us, we can do a lot more in the way of just doing question and answer and stuff like that. But what we're going to start out with is, and I'm gonna fly through these slides. This deck has like 81 slides in it, but don't worry about that. We're gonna rock and roll this. I'm gonna talk about some OWASP tools. The first one I'm going to talk about is the the OWASP Top 10 Proactive Defenses. So OWASP is the Open Web Application Security Project. It is the preeminent application security organization in the world. Now, there's a number of security organizations in the world. And one of them is like ISC Squared, which is the organization that proctors the CISSP exam, which is basically the CPA of security people. It is not application security specific. It is general security specific. So you talk a lot about policy and risk and network security and physical security and stuff like that. That organization is part of the reason why, if you go to a security conference, lockpicking is taught as a hobby. It's how I got into it, actually, back a while ago. It's DEFCON 13, so it would have been 14 years ago. I learned lockpicking because of people teaching lockpicking at DEFCON, which is the biggest security conference in the world, and which is probably, that's another funny joke. Probably not gonna be held this year. Anyway, the CISSP is a very broad thing. OWASP doesn't do any certifications. It's basically a big GitHub repo with 41,000 members, people members that organize 3 things. One is conferences, and actually there's going to be a conference, a virtual conference at the end of April. And if you go to OWASP.org or check my Twitter feed, you can see that conference being organized right now. They're going to hold a mini conference and then some training for a fee, but that doesn't matter. The conference is completely free, and it'll be just fine. And then we hold chapter meetings, which Columbus held our first ever virtual chapter meeting 2 weeks ago via Google Meet, I think, and that went really well. We're probably going to be doing that again this month with the way things look. But generally speaking, we meet the 4th Thursday of every month. And we meet around town. We meet at Cover My Meds and Improving. They're real good to us. And Cardinal is actually where we're supposed to meet in May, but I don't even know if that one's going to happen the way things are going. We've been meeting online, and that went super great. But we talk application security. So we've got conferences. We've got the chapter meetings. But what we're going to talk about today mostly is projects. So the projects are tools that are built by members and then donated to the OWASP organization as open source projects that are one of 2 kinds. They're either documentation projects, so tools that enumerate things like best practices or guidance for securing your applications, and then there are software tools, which are along the lines of things you can use to either test your application or defend your application. So we're going to talk today about, since it's a small group especially, I'm going to riff a little bit, and we're going to talk about a couple of the proactive tools, a couple of the documentation tools, and then we'll talk a little bit about a couple of the software tools. And we're also going to talk about some software tools that aren't OWASP projects, but are still very useful, especially for front-end people. So let's do that. So I'm Bill. This is my slide. I think probably many of you here know me. I'm a Microsoft MVP. As it turns out, software security is kind of platform neutral when you deal with web application software. It's pretty broad. So it's funny that they kind of, even though I do a lot of stuff and have written a lot of books and stuff for Microsoft things, it wasn't until I could break into their software that they were like, hey, let's add you the MVP program. Yeah, great. Thank you for that. This is what I just said a minute ago. I can make all these slides available on the event tool. These are actually OWASP slides, so they're available on OWASP.org, to be honest with you. So this is the standard 3-paragraph mission statement kind of thing. And this is true. If at the end of this, if you found this interesting, we desperately need front-end programmers to be involved. A huge portion of the OWASP world is back-end driven because we're all old. And it's the server is a lot of places where people are concerned about, but the browser defends the individual users. We'll get into that a little bit. We don't have nearly enough people that are specialists in the front end doing work. And one of the tools that I'm going to show you today, it's an OWASP tool, is specifically about the front end. Actually, 2 of them. One is an OWASP project and one isn't. But we need far more research and insight. And the fact that you're not specifically involved in application security doesn't immediately matter. We need the technical help. I mean, I myself, not a great front end dev. I'm okay, but I mean, I learned HTML in when it was written in '91, and didn't stay up to date as I moved on in my career path. So I think a lot of people that are involved in OWASP follow along those exact same lines. So this is uniquely worthwhile to talk about this with people who specialize in front end. So we're going to talk about the proactive top 10. I got myself on a tangent and forgot to talk about the top 10. So the documentation projects, the most famous documentation project in OWASP is the OWASP top 10. It's the top 10 vulnerabilities. If you search OWASP top 10, I'm hoping everybody can see my screen. Wow, lots of ads. That's just terrible. And here are the top 10. As you can see, they're all written in security language. You know, injection, XXC, security misconfiguration. None of these are rules that developers can follow. These are all written in terms of what the security people would want to look at. And it's useless to us. Even though OWASP is a developer organization, it was largely started by security people. So instead, we built the proactive top 10, which is an OWASP project. You know, it's verified and peer reviewed and the whole deal, which is basically the same things reviewed from the other side, right? So it's, instead of injection, we say what to do. So step one. So this is what we're going to talk about. We're going to talk about 10 things you can do right now to make your application more secure. Step one, parameterize your queries. What do I mean by that? Well, famous XKCD you probably have seen. Did you really name your son Robert Tick Paren semicolon drop table student semicolon dash dash? Oh yes, little Bobby Tables. So the punchline is, I hope you learned to sanitize your input. So what's that mean, right? That means we're going to take the data that's coming in from the user, and we're going to make sure it's the data that we want before we try to inject it into a service or a database, before we try to do an insert. But it's wrong. Why is it wrong, right? So here's an example. Is this a valid email address? As it turns out, it is a valid email address. You can't sanitize every single input. Sometimes you have to just accept what the user gives you. So when you're inserting into a database, one of the things you need to do is parameterize your query. So here's an example of some back-end code where we're talking about the picking up the request object. So this would be service code on the back end, right? Kind of pseudocode, sort of PHP-ish, where we get this email out of our request object, and then we go through a couple steps, right? So step one, we're going to look at okay, hang on, messed that up, sorry. So step one, we're going to look at we've written an update statement, and then step two, we've got that email address is that tick-OWASP at OWASP.org, right? And then step three, you can see how we have now set the email address to empty, right? Because we've got 2 tick marks there in a row. So set email equal to nothing, empty string. And what happens is that because of the dash dash, all the rest of that query goes away. So now we have updated everybody's email address to nothing. And that's just one example of what can happen. So what we need to be doing here is building parameterized queries instead. So for instance, in PHP, we can use the prepare statement and bind param to run parameterized queries. In .NET, we can use the SQL connection object to build parameterized queries. And what is this? Is this Java? This is Java. I should have. It's funny. I'm using the OWASP slides instead of my slides. And there's no notes, so I'm having to take a look. Oh, I see. There's some HQL. So that's Hibernate, right? Interesting story. Even Hibernate can be injected into. So you need to make sure you can use these parameterized queries rather than depending upon your input validation. Then oh no, here's the PHP I was looking for earlier. Every language has some kind of parameterized query collection that you can use. And so that's just one example of how best to get the data you want into place. In general, the parameterized queries piece applies to a lot of different pieces of software application design. It's not just databases. It can be LDAP. It can be XML, believe it or not. There's a lot of things that you can use, but use the tools at your disposal to make the software do the work for you. That's what we want to do. So number 2 in the top 10 is encoding data before use in a parser. There isn't something that we can talk about more important in the world of JavaScript than this exact piece, is encoding data before use in a parser, because guess what a browser is? It is an HTML parser. That's what it is. And you can attack the browser very easily if you know what you're doing, and you build JavaScript to build it. The realities of cross-site scripting, which is probably the premier attack on a browser from lack of encoding into a parser. A lot of people, especially if you've been around the web for a long time, think of cross-site scripting as something that's about defacement. It's throwing a virtual brick through the window of a virtual building, right? But in reality, it's far more involved than that. There's a tremendous amount of stuff you can do within a browser that is detrimental to the end user. So let's talk for a second about injection versus the browser encoding. On the injection side, the reason that injection is A1 on the OWASP top 10, it's also on the practice top 10, but on the OWASP top 10, is because if I can attack the server by injecting my code in the server, I can affect all the users at once, right? I can do a fair amount of damage to a lot of people. I might be able to steal everybody's information. If I can inject code to the browser, I can still do damage, but I only get the damage one user at a time. So a lot of people kind of underestimate how important this attack is. So they focus on, and I do this in my testing, focus on the server injection pieces rather than focusing on the user experience, which involves all of these pieces of phishing and redirection flaws and theft of data, logging keystrokes. Now we've got this slide's a couple years old, but Bitcoin mining is a big thing that's done with browser injection these days. It's a big deal, and people overlook it. And what it basically comes down to is the reality of when you're absorbing input from the user and then putting it back out to another user, changing this to this. That's really what it comes to, is appropriate encoding of your data. But as it turns out, encoding is really hard for the browser. You have to encode contextually for each different kinds of piece. And sometimes you have to do things like accept HTML, which by default can't be encoded, right? Because it's supposed to be HTML, right? Or cascading style sheets where it has to pretty much be that way. So what do? So there are tools out there, OWASP projects out there, like the NEXSS library, that will help you with this. This isn't it's not on Codeplex anymore. Obviously, it's on GitHub now, so the image is a little out of date. But Microsoft has done a tremendous amount of work for this. Barry Dorans is the head of ASP.NET security. So he's done a tremendous amount of work with the system.web.security namespace. So Microsoft has a lot of this built into .NET if you're working in a .NET world. In the Java world, there's an OWASP project, which is really cool, called the OWASP Java Encoder project. It doesn't have any third-party libraries, and it's a very broad, complete API that you can use to do encoding for your projects. It's a bunch of examples of the contextual stuff that they can do. And once again, I'm flipping through these slides so I can show you some other stuff too. You can get the slides easy if you want to go back and refer to it, not a big deal. But they talk about the context of HTML itself, right? So if you're actually having to write HTML to the screen using JavaScript, or using your backend code for that matter, XML, cascading style sheets, JavaScript itself, like if you're doing dynamic JavaScript, which is extremely dangerous. So we'll talk about that in a little bit. And then of course URLs. But every platform has something. Some of them are better than others. And I'll, you know, like I said, I'll have all this available to you. I already talked about the different kinds of encoding we deal with here, but there's a lot of the point is that you need to contextually encode your output before you give it to the user. You can do that in the browser, or you can do it before it gets to the browser, but you've got to do it. Okay, so number 3 is validation of input. Now, in the first 2 sections, I told you that validation of input doesn't matter that much, but the fact is it does. You just also have to do things like parameterize your queries and encode your outputs. Those are the most important things. We put the defense on the outside, right? It's super awesome if we have defense on the inside of the house, but wouldn't it be better if we have defense on the outside of the house first? And that's what those output encodings and parameterized queries do for us. But we also want to validate our inputs. And there's a collection of tools that make that easier, but there's a lot of problems with this that I mentioned earlier. Like, for instance, and I'm sure some of you use TinyMCE or some other inline HTML editor. The truth is that sanitizing HTML before you save it in the database is extraordinarily difficult because HTML changes all the time. People use fancy character sets to get by encoding things. They find little twists. It's such a nightmare. If you're going to accept HTML or any version, any other part of HTML like style sheets or JavaScript itself before you present it out to the user, the sanitization of that input is extraordinarily difficult. So there is an ongoing project, the HTML Standardizer project. It's written in Java, but it's usable by almost anything. I have a client that uses it in a Ruby on Rails project, believe it or not. And it is, it's really neat. It will allow you to build rule sets for your inputs. And it's very nice. So that's something to look into as far as input sanitization is concerned. But once again, everything has something that you can use. In the .NET world, there's the NEXSS project and the Get Safe HTML fragment piece. There's new gems in Ruby, and there's lots of pure JavaScript tools that do input sanitization. Now you have to remember that if you are, which I'll show you here in a minute, if you're using your using a service tier, that your JavaScript on the front end and your browser code, I mean, an attacker could bypass that, as I'm going to show you in a little bit here. But it's still really cool to be able to do some of that sanitization up front. At least for the user access perspective. And then there's a handful of other details in here I'm not going to go over right this minute, but that's okay. Okay, so implementing appropriate access controls. So broken access control is one of the things that we talk about a lot. And there's a boatload of access control anti-patterns. And I'm not going to go over all these right now, because this is a front-end group, and most of these are way back-end systems. But there's a lot of bad ways to do access control. So access control is, of course, authorization. It is the who can do what within the application. So for instance, you know, you might have code that says, hey, if the user is a Jedi, a Padawan, a Sith Lord, or a Jedi killing cyborg, then you can use a lightsaber. But now, of course, we've all seen Star Wars. We know that ex-stormtroopers and random people from the street can occasionally use them under certain circumstances. So if you have to modify your code every single time that happens and deploy a new version, you're going to introduce errors. Complexity is the enemy of security, and we want to try to avoid that. So instead, we use claim-based security on the back end. And that's a term, I'm not going to dig into it deep today, but a term you can definitely go look up and play with if you're doing authorization stuff, where you can assign individual credentials to someone and have them be able to go do their piece. So we'll deal with that later. Okay, so establishing authentication and identity controls. One of the key things we have to remember as front-end folks is that the authentication controls we put into the browser code, so the JavaScript, the HTML, can be completely bypassed by the attacker. And we'll look at that in a minute in the demo. And the attackers have an insane number of really good tools to attack our authentication systems. So what do we do about that? Well, there's a few things that we do. One is, do not, in your front end code, limit the total length of the password within reason. And if the back end code is limiting it, then you need to have a discussion with somebody. So you don't want to allow somebody to paste the contents of War and Peace in there, because hashing that with a hashing algorithm will burn the server to the ground. We don't want that. But we don't want to prevent somebody from putting in a 64-character password if they want to, because a lot of people use password managers now. And so it doesn't matter, because we're going to store the hash of the password anyway, and we can let them put in a 64-character password if they want to. Then when we're storing the password, well, I'll be honest with you, I don't agree with this statement anymore because of another reason. But don't worry about that. I prefer if you use a key derivation formula with a work factor, but we won't worry about that today. So impose some kind of difficult verification on the attacker. This is this is a funny thing, because this is exactly what I was talking about in the last slide, is using PDK-DF2 when you want to store a password. Okay, and yeah, okay, it does take a salt, I guess. So maybe the last slide is okay. Using a key derivation formula when you store the password makes it extraordinarily difficult if the attacker were to intercept the password from the server, for them to be able to reverse that password. So that's something that if you're using a identity system like Active Directory, for instance, it's taking care of for you. But if you're storing your own passwords, you have to concern yourself with. But you want to impose that difficult verification on only the attacker, right? So you want the user or the service tier to have a simple path. So for instance, how many of you have a organization that says, okay, you have to have a 10-digit password with a capital letter, a number, and a symbol in it? So I have a client that does that, right? And so we collected their database hashes, and as it turns out, about 7% of the hashes, once we resolve for the salt, because we're on the back end, right? So we can do this work. Once we resolve for the salt, the hashes were the same. Why? They were all capital password one bang, because that's what people do, right? So imposing those strange constraints on people, rather than just having them do long passwords, doesn't necessarily improve your authentication security. Very interesting that one of the first places to implement two-factor authentication, multi-factor authentication, was the gaming companies, World of Warcraft, League of Legends, stuff like that, because stealing of accounts was so common because, of course, largely they're played by 13-year-olds who put in their dog's names, their password or whatever. But now it's becoming significantly more more popular, and using those tools, those second factor tools, is probably your best bet. So when you need to do a password reset, there is a known forgot password flow. And this is a hard to read version of it. If you go to OWASP.org, which we will here in a little bit, you can see a nice graphic of it that I need to go in and replace this slide one of these days. And these slides are all open source, so you can contribute to them. But there's a known piece of this. There's some good resources here. The authentication cheat sheet on OWASP's website. Once again, that's stored in GitHub. It's easy to access, easy to read. Also, password storage and the aforementioned forgot password cheat sheet is another piece. Get these because I'm going to go over ASVS in a minute. Okay, so data protection. So one of the things that I really like about the OWASP Top 10 they just changed is data protection, because it used to be about protecting the company's data, and that's all they talked about. But now they're very concerned about protecting the end user's data as well. And that's the way it should be. So it's now called data protection and privacy, which is super nice. There is no reason at this point in time ever to not have your website under the constraints of TLS. There's never a reason to have a URL that isn't HTTPS. It used to be, it puts load on the server, it's too slow for the user, not all the browsers support it the same. Yes, those things were all true in the 90s. They're not anymore. TLS is often faster because of the compression protocols used. It is standardized, especially now that we've moved from SSL to TLS, way more than it used to be. And it is definitively protective of the user. So there's absolutely, oh, and right these days, even more importantly, okay, not more importantly, but as important, it authenticates the server, right? We're authenticating that we're connecting to the server we think we're connecting to. And that is extremely important. So there's no reason not to be under TLS. I'm not going to go over details on that because, there's a bunch of, as it turns out, encryption is difficult, right? So this is more of a back-end thing, but I like the slide. The rule is for developers, don't try to roll your own encryption. Whether it's encryption of data in transit or encryption of data at rest, you're not going to be able to roll your own encryption. My classic was at a State Department that will remain unnamed. I was told by the developer team lead, oh, Steve or whatever his name is, yeah, he's building our encryption protocol. He's like he's a chess grandmaster, so he's really good at this. And I'm like, oh. These protocols are vetted for years and years by hundreds and hundreds of people that have been studying encryption and mathematics their entire lives. There is no chance that one dude on your dev team is going to be able to build an encryption protocol for either encryption of data in transit or at rest that is going to pass muster. So don't try. All right. Now for a second, take a sip. Okay. So super important. Logging. So glad they added this to the top 10. Our applications need to be telling the security team when there's a problem. So, for instance, and once again, we'll see this in a minute with the demo. Wow, that more thing keeps coming up. Oh, there's stuff in the chat. Okay. Hey, if there's, let's take a break real quick right now. If there's, let's look and see if there's questions, because I just noticed there's stuff in the chat. Oh, okay, it's just you guys just chatting. Oh, there's, okay, if you haven't looked at the chat, look at the chat. There's some good stuff in there. Yes. Phrases, yes, phrases are fantastic. So the reason why the banks limit you to 8 characters with your passwords is because they're using RACF on the back end. So for the kids in the audience, I don't think we have any in this particular group. The RACF is a AS400 DB2 mainframe-ish authentication protocol that is very commonly used by banks. One of my clients uses it. We have the same problem. I've been officially restricted from writing them up on their reports for 8-character passwords because they can't do anything about it right now. So yeah, it's a real thing, and it is a big deal. Oh, I got a question on Twitch. Okay. How would you design a .onion website for security? Oh, you know, so yeah, there's I mean that tell the person tell the person who asked that question to ping me on Twitter, and I'll tell them a funny story. Custom question: do you want others to have access to your money? Custom answer: no. Yeah, that's very good, Matt. I like that. Anyway, so that's the reason, is because there is literally a copybook in COBOL that has an 8-character field for your password, and it's storing it like that. And it is extraordinarily expensive and difficult to fix that under some circumstances. So that's why you get the banks that restrict you to the 8-character passwords. If you are storing your passwords correctly, which is hashed and salted, or, well, I'm sorry, I fall back into old patterns sometimes, using a key derivation formula, you're going to end up with a hash, and all the hashes are going to be the same. You can have a 2-digit character, 2-character password. You can have a 200-character password. It'll always be 64 characters or 128 characters, depending upon what derivation formula you're using. And when we're working with a modern database like SQL Server or Oracle or one of the document-oriented databases, then it just it just tosses that in there. You know what I mean? And we can modify that almost on the fly. Not so with a mainframe, like a mainframe style database on like DB2. It is extraordinarily demanding to make those changes, and it impacts all the other users like right then. So it becomes a big deal. Okay, well that was good. We stopped for questions. That's good. I like to stop for questions. Okay, so oh, intrusion detection. So applications should inform the security team about attacks, and I'll try to show you this real quick in the demo, but just in case I don't get to it. For instance, let's say you have a form that is let's say like states in the U.S., right? So it's you're starting as a 2-character field, OH or KY or whatever, and you have a drop down, a select, an HTML select, all right, with items, and it gets one of the items you get is 181, like the digits 181. That the person who posted that clearly did not use your form to post it. They used an attack tool. All right, that's what happened. They used an attack tool to post that, and you need to report that to your security team as an attack. So self-reporting applications become very important, and sometimes you have to build that into the service tier, and sometimes you have to build it into the front end. But you always need to be reporting it, because it's very it's a very important piece for the security team to know about. And their tools, their web application firewalls and whatnot, the blinky boxes that they put up to find things, won't always get stuff. The best way is for the application itself, who knows what its input should be, the best solution is for the application to report it itself, right? So that requires a lot of extra coding, and that's sometimes really hard to get into the requirements document for an application. But there are tools that will help you with the cross-cutting concerns like that. An example is App Sensor, which works in the Java environment. But there are others that are useful in this tool set too. And if you go and look, and I'll bring up the OWASP webpage later on, you can see all the tools that you can bump into there. Okay, so leveraging the security features of frameworks and security libraries is number 8. I like this one a lot. It is one of my go-tos, because one of the things I discovered, so for a couple of you who maybe don't know my background, I've been a Microsoft developer since '93. I mean, a long time ago, before they knew how to spell internet, and learned ASP Classic and VBScript, and then was one of the first people on .NET, and have written a ton of books on .NET and written on books and a bunch of articles, and I'm very involved in the Microsoft world that way. These days I'm kind of cross-platform, but historically I've been very Microsoft centric. I had to, one of my last significant projects that I was full-time coding on, I gradually moved into security from development, was building out an authentication system for a tool that had no authentication. I mean, it was, well, this is behind the firewall, so we don't need to log in. So there was no identity store, so I had to build one. So I wanted to use PBKDF2, and I was shocked that I couldn't find, I mean, I would have to write all this code. And as it turns out, PBKDF2, the key derivation formula I was talking about back in the password section, is built into .NET. It's just called something obscure, like it's by its RFC number, RFC 2393 or something like that. System.security.cryptography.20 RFC 2393. I have no idea why they named it that way, but it's in there. Use the tools you're given, right? So it is, that's funny. Use the tools you're given, right? If your platform has a built-in authentication system, use it. If it has a built-in authorization system that meets your business requirements, which is usually the problem, use it. If it has built-in support for cookies security, for instance, for like session cookies, use them. Don't handwrite this stuff. Use the platform tools. we're obviously we're online here instead of all meeting someplace cool because of a virus. And one of the things we're eventually going to have is everyone is going to either via hopefully a immunization shot, or unfortunately catching it, is going to be immune to this virus, right? Lots of people are involved. We're depending on the herd. We're depending on the group to stay home right now until everything catches up, and then we'll get back together. Well, the same thing is true in libraries for application security. So many people have used it that all the security problems have been vetted already. If you write something yourself in the security space, it won't necessarily have, you won't get as vetted. You'll only be an N=1 case. If you use ASP.NET Identity, for instance, you will be able to benefit from the hundreds of thousands of other projects that have used it and already found flaws. So that's there. Okay, so security requirements. Super awesome topic. I love to talk about this. Security requirements. Really tough right now in the development space to get companies to let you code in security. It's really tough. You build in these lists of ideas to do security pieces, then you estimate them and add cards to your deck, and they're like, whoa, this is like way more than we thought it was going to be. It's tough. It's hard to get business units to agree to these things. The easiest way I have found to leverage it is via a really cool project called the ASVS, and we'll take a glance at it in a second. The ASVS is the Application Security Verification Standard, and it was originally designed to give like organizations that build tool sets a way to show that they've met a certain security standard. So there's basically, well, there's really 4 tiers, not 3, of requirements that need to be met over 17 different verticals. So tier 0 is, we haven't even thought about security. Tier 1 has this list of requirements. Tier 2 has this list of requirements. Across all these topics, we've covered input validation and output encoding and encryption and authentication, authorization, all these different pieces, right? And you can be audited. There's actually an audit spreadsheet. To be honest with you, that audit spreadsheet, modified slightly, is what I use to do application verification assessments. So you can go and say, oh, we've built this tool set to manage your customers' data, and it's ASVS level 2. And that's the way it was designed, but it's not just for that. It can be used by developers, by you guys and me and everybody, to go in and write the requirements, because those testing points are the requirements. So it's this big 180-page document of all these non-functional requirements. We call them in the design world, the architecture world, but well, some of them are functional, but most of the times they're called non-functional, that lead to more secure software. And you can, I mean, it's open source. You can literally just copy them and paste them into your your tool set to go explain to your end users or your business units what needs to be done as far as security requirements are concerned. And then the final step we talked about is security architecture and design. It rolls very nicely from the ASVS. This is about building a culture of application security, which I have a whole nother talk about. You can probably find on YouTube. It's difficult to do this. This is about going back to the business owners and sometimes even the software architects and dev leads and like that, and helping structure the company to be more security first focused. I've got a customer that's a consulting company. It's one of the first times I've had a consulting company come to me for this. It's very cool. They build websites for hundreds of people, hundreds of places, and they are building a security infrastructure internally for their developers. So it's not even just like a bank or an insurance company or somebody who has to meet a specification because of HIPAA or PCI or one of these other security standards. This is an organization that simply wants to build security infrastructure into their development process because it's the right thing to do. And that's what step 10 is, the 10th item is getting the overall feel of the organization to be more security focused. Talking about how to trust input or not trust input, how to set trust zones, how to define your attack surface. That's kind of what, once you've got those first 9 nailed in your mind, the next thing is step 10, going to the organization you're with, or if it's just you, I mean, implementing. The step 10 is implementation. It's super cool to sit in, well, in a conference room, but we're not, in a web chat and talk about this stuff, but eventually we have to do some implementation, and that's what step 10 calls us to do. So that's it for the slides. I'll take any other questions anybody has, and then I'm going to show you a project or two, and we'll go from there. So any specific questions?
So, Bill, there was a question on Twitch, like how you will go with developing an website from scratch with security perspectives. So, are there any guidelines document for web applications?
So if you're working from a greenfield project, right? The key pieces are to use the components of your whatever platform you have. Use the components that are built into the platform. So authentication components, encryption components, pieces like that. That's undoubtedly step 1. Use the pieces that are built in. And then if you can and you have budget, get a test done before you deploy. Get a vulnerability analyst. I do it. I'm not suggesting that I'm the one who should do it for you, but there's lots of them out there. If you need references, there's plenty of places that can do it, but get a test done. Somebody who knows all these attack features. We're not going to have time today to go over all of the attack pieces, but I'll give you a little bit of an overview of some attack pieces, so you can get an idea of how to look at it yourself. And that's probably step 2. Even if there's no budget to get a test done by an organization that specifically does it, you can do some of it yourself. So I'll show you some of that now, unless there's another question on there.
Thanks for having the class. I work for the fraud prevention, and I know that there's a lot of techniques that we use. Just looking for SPs in different states and stuff like that. we have that capability outside of business.
Jennifer, you're breaking up a little bit. Can you type it into the chat?
Sure.
And I'll answer it.
Yeah, feel free to send your question in chat.
Can you guys see, while she's typing, I see she's looking at her keyboard, so that's good. What can you guys see my dual screen here? Oh wow, okay, yeah. This question's gonna be stressful. Jennifer, while you type, I'm gonna talk about JuiceShop for a minute, and then we'll go back to that real quick. So we're gonna talk about a tool. I really shouldn't use Zap instead of Burp. That's okay. We're gonna talk about a tool that is an OWASP project called JuiceShop. It is a purposefully vulnerable web application that has flaws in it on purpose. And it's a great way to test, and I can show you how to deploy a copy real quick to go and practice using an attack tool. So that's what we're going to, I'm going to show a little bit of that real quick. I wonder if I can, I put up, I wonder if I can get Zap up. I don't even remember if I have Zap installed on this machine. There's different tools for ISPs in different states, things like that. Is there any way we can do that personally? Oh, no, wait. Oh, wow, yeah. So that's a good question. That's more of a that's outside the scope of application security a little bit, and more in the scope of network security. That's let me think about that for a minute. Wow. Yeah, I'd have to defer. Shoot me an email, Jennifer. Here, I'll have to defer to one of my people who do DRC to answer that. I've got a bunch of them. They can get that in there, but that's a policy question. And it's a good question, but yeah, shoot me a note. I'll hook you up with someone that I know who can answer that for certain. I do not have the answer to that off the top of my head. So I'm gonna punt here real quick. Hang on. Ooh, this is gonna be really interesting. Nope, I'm not. Okay, never mind. All right, so so OWASP JuiceShop is a purposely vulnerable web application. It is written specifically. Yeah, I know. Hang on, I now messed up my environment a little bit. Sorry. Yeah, no, don't start. Just stop. I screwed up a little bit. There we go. Okay. So it is written to have flaws in it for you to find. So you can try things on it. So a couple of things I'm going to show you here. You need to know you cannot do this stuff in public. Okay, you can't, don't think to yourself, I wonder how secure my insurance company is, and then fire up a proxy and attack it. You will go to jail, and I don't need to know that happened. So please don't do that. But more or less what's happening here. So this is JuiceShop. It is a website. You can click on it and look at the reviews, and you can go to your shopping cart, and you can look at the menu, and you can look at your account. Oops. That's not the way it's supposed to work. All right, well, that's okay. We're not going to use that right now anyway. Over here on the, well, my right, yeah, you're right too. On the right-hand side of the screen is the proxy. So the proxy is recording all the traffic that's going between the website, which is loaded in my browser, which is Firefox currently, and the server, which is stored up on Heroku, which you're probably all familiar with. And if you're not, it's a hosting company. It's a cloud-based, easy to deploy to hosting company like Azure or AWS or anything like that. I think Heroku hosts this stuff on AWS. Now I think about it, but they have a nice deployment chain and all this fancy stuff. It's really complicated and very cool, and I like it a lot. And we'll look at something there, but that's not the point right now. The point right now is that I'm running this website on my browser, and I've configured my browser to use this as a proxy. And so all of the traffic is being stored here. So if I go and look at a product, you can see this here, this get statement, right? I can see what's actually happening under the sheets. Unfortunately, I've been here recently. There we go. There's a good one. So I made a request to the API right here for reviews, and I got a response back with all the details in it. Now, there are known flaws in this application, so I can recommend you to go get this application. Let's talk a little bit about them. How many people have used JWTs, Java Web Tokens? Anybody raise their hand? Yes. All right. So there's a tool called jwt.io that is not an OWASP project, but should be. And you can go and debug your JWTs using this. If you don't know about this, you should. Now, that is obviously decoded our JOT, right? To a developer or a user, most developers or a user, this looks like a bunch of encrypted gobbledygook. Is it? No. This is not encrypted, it's encoded on purpose, right? Because we don't want to be doing, well, that's not true. It's encrypted on purpose because this is a purposefully vulnerable application. That's why it's encrypted on purpose, or encoded on purpose, not encrypted. Do you think that token should include the password? Probably not, right? You know, so what we've done is I sent a request in. I was already logged in because I wanted to get set up. I sent a request in, so I have a bearer token. That's the way JWTs work. If you haven't used them before, they build a token. I copied the token, I pasted it into jot.io, and I go and look at it here, and this is what's actually in this, right? So we can do things like that password, that's clearly not my password, right? I didn't type all that in. No, that's a hash. Anybody, well, I'm not going to ask because normally I'd say, anybody know what hash that is? It's an MD5 hash. So we could do things like maybe Google that. Oh, look. Yeah, I literally Googled the hash of my password and found it in Google. Right here, there you go. That's it. That's my password. You can now go hack my website. Of course, if you have a very complex password, it might not be in Google, but if it's stored in MD5, it's very, very simple to reverse it. That is definitely the way it goes. Whoa, hang on. I apparently somehow set off my phone. That's really weird. It's never happened, I don't think. So we talked about secure authentication, right? So some of these things take a little bit of practice, but going and poking stuff like this, right? Looking at the actual requests and responses, not just what's happening in the browser, is the key to web application security, and these tools help you with that. I'm using a tool here called Burp Suite. It's a paid tool. It's not an OWASP project. There is an OWASP project, however, called Z Attack Proxy, ZAP. Daggone, I keep loading that thing up. Right. So here's Z Attack Proxy. You can go. It's on the OWASP webpage. You can just Google it like I just did. OWASP ZAP. And it is the same. It's the same tool basically. I didn't think about the fact that we were talking OWASP and didn't make sure it was updated on this machine. And normally I would present with it, but I use Burp day to day because it's what my clients need me to use, because that's what they have, so that we can share the results files. Okay, I love Zap. Simon Bennett's is a friend. He's the main developer. It is actually a Mozilla. It's paid for by Mozilla. Mozilla pays Simon's salary and a couple other people that work on it, as far as I know. And then they build it and donate it to OWASP, which is just freaking amazing if you think about it. But it does the same thing. I'm showing it to you in Burp, but Zap would do the same thing. And Zap is free, open source on GitHub. Go get it and play with it. You just read the install guide. Just a little bit of trickery, because you have to trick your browser into routing your traffic through it. But it's definitely worth the time to do. And going and looking at these request and response pairs is where all of the magic happens. So I just gave you one example. Go and look at this and say, I wonder if this is an encrypted blob or not. You could even right click. I can send this to something called the decoder, which is one of the tools in Burp and is also in Zap. And it goes to the decoder tab. And I think I can decode it. It's base64. See? And it's still all in there. It's not quite as pretty as jwt.io, but it's all in there. That's the kind of stuff that you can do. You also can go in and resend stuff. So for instance, let's say we wanted to do a search for an item. I always misspell banana. I don't know why I do that. Okay, so we did a search for, oh, that's right. They changed that. Daggone, that's one of my favorite freaking pieces. So I added banana to my cart, right? So it did it. Wait a minute, I added it to my cart, didn't I? Add the basket. There you go. Oh, that's a GET request? That's ridiculous. Oh, I'm not logged in. Okay, that's all right. We won't worry about it too much. The JWT expired. That's funny. You can go and you can attack it in an automated way. And once again, Zap does this exact same thing. But you can go in and say, we want to do this. We're going to attack that field. All right, so I'm going to wrap that field in the little paragraph markers, and I'm going to attack it using my fuzzing list to see what kinds of things I can break. And it will start an attack. And we're going to get unauthorized on everything right now because I'm not logged in, but that's okay. But that's I just wanted to, I don't want to take up your entire evening, and that's what I wanted to point out, is that's how attack proxies are an important part of your tool set when you're testing your own applications. It's something that's worth learning how to do. Now, right now, if you are locked in your house and bored, right now, Pluralsight is free in April. Okay, and there is a set of presentations by Troy Hunt. I can probably pull them up. Hang on. No, I'm not gonna be logged in here. I don't remember my password because this is my attack system, so it doesn't have my passwords and stuff. Troy Hunt, Troyhunt. He is a Microsoft MVP out of Australia. He used to be a software architect for somebody big, I don't remember who, and is a security specialist. He runs a website called Have I Been Pwned? Yes, I'm human. Oh, okay. See, this is why I can't use this browser for this stuff. Anyway, that helps you. You can find out if your accounts have been stolen. He tracks a bunch of stolen account information. But you can look up his classes. He has put a bunch of security classes on there. He is one of the 10 best application security people in the world, without a question. He has studied it his whole life. He's very well spoken, and he is remarkably talented. And he talks. He can teach you how to use this. These pieces. I also have a bunch of classes that I've done. You can find on YouTube easily by just searching for my last name. And also, if like your organization happens to have a Winelect Now subscription, you can. Once again, I'm in the wrong platform to do that, to demonstrate that, but you can go look at Wintellect. I've got some testing tools there as well. But that is the that is the way to get to the next level on this, is you basically learn a basic tier, which I kind of went over here. You know, you can go in and look at the request response pairs. Those socket attacks are stupid, right? Go and look at these things, these request response pairs, and go in and change them and look at what's in them and find out what's going on, and then make attacks happen. And that's what these tools are for, the Burp Suite tools and Zap tools. For instance, Burp Suite has even a scanner that you can use. You can go in and do authentication scans, right? You can give it a URL and it will go and try a bunch of scans based on the URLs it's already seen. So you can even automate this. Zed Attack Proxy has an API you can build into your platform to look at things. It's very helpful. But one thing I definitely wanted to talk about, and I don't see that I have it loaded, which is really weird. Hang on for just a minute here. Give me a second. I'm going to maximize this. I'm going to try to maximize this. There we go. Is this? Okay, so let's talk about retire.js. So this is a front end piece. Front end group, right? A JavaScript group. Retire.js is the project, right? JavaScript, the number one problem we have is out of date components. In OWASP parlance, it's out of date third-party components, something you didn't write, right? Usually out of date jQuery or jQuery UI. That's the two biggies. jQuery has stopped updating all the 1.x and 2.x builds for security. If you're not in 3.x, you're not getting security updates anymore. So if somebody finds like a cross-site scripting flaw or an injection flaw in 1.x or 2.x, the jQuery Foundation is no longer fixing those. So you can use retire.js to find out-of-date versions of your applications, and you don't even need a proxy to do it. Retire.js has a command line tool that you can add to CI/CD builds. You can use a browser plugin. I found I didn't even know they had that until like 2 weeks ago. Been using this tool forever. Lots of really good stuff. So definitely the leverage the community, right? And the people that are keeping that database up to date and letting people know what is out of date and what is potentially vulnerable. That's definitely something worth doing. I wouldn't keep like the browser thing installed all the time, but having it in there to go look at your applications that you're building is a relatively simple and extremely important part of all of this. Okay, so beginner certificates and SANS is a question. Yeah, Bhaskar put a link to hacking JWT in there. That's good. I don't know Joel Lord, but that's definitely worth a watch, I'm sure. Beginner certificates and SANS. So I'm not SANS' biggest fan, to be honest with you. There is an application security course that has been tweaked by Mick Douglas, who is a friend and an excellent security professional. And I don't remember what it's called. Hang on for just a minute. I will look it up. But SANS is not so SANS is a wow, how can I say this politically correctly? There's a lot of just doing it for the money in SANS. It's a little frustrating, to be honest with you. But honestly, if you're funded for it and you get the right instructors, the instructors make it. That's the problem. They've got all this courseware, but the courseware is just slides with bullet points on it. If your instructor is good, you're golden. If your instructor is not good, you're not getting anything out of it. Training is hard. It's hard. But there is a the beginning application security course. Dev 522. Dev 522, that's the one that Mick worked on. Jason's last name. He worked on it as well. Those are good courses. That's a good course. They're two good instructors. And you can get something out of Dev 522. It is not what we talked about here, which was testing. It's defending. So it's a little bit secure codey. And that's rough because writing good defensive code is very platform dependent. So it's super easy for me to say parameterize your queries, but it's harder for you to implement that because it depends on what platform you're using, you know? Everybody does it differently. So in my injection talk, my injection training that I give, I've got like 9 slides in a row that show how it looks in everything from Java J2EE all the way down to Perl, you know? And I go through before I do my training and blank out hide the ones that don't apply to whatever client I'm giving the training to. And that's the problem that SANS runs into with the secure coding piece, is that it's really tough to have a stable of trainers who can go in this week to a Java shop and next week to a Ruby on Rails shop and teach secure coding in both places. That's hard. And that's extraordinarily hard. Even somebody who has a strong background in development probably doesn't have a strong background in development of every platform. So it's tough. Training's hard. What I strongly recommend, I like in-person training. I give it But truly, if you can use the online platforms and go to the conferences and just build a environment that you know, loves security, that's your best bet. So yeah, so that's all I've got. Unless there's any other questions, it's almost 8, and I'm sure people have stuff they want to do. But if I'll take any other questions anybody's got, if you want to hop on, or if anything's on anything else is on Twitch, not Slack, Twitch. I'm not logged into the Twitch channel, so I can't see it, Bhaskar.
Yeah, we don't have any other questions on Twitch, Bill.
Okay. Anybody on the call have any other questions? No? So I'm super easy to find. I think I closed my presentation. So hang on for a second. If you want to find me, you can find me. I'm at Sempf on Twitter. And bill@portweb.net is my email address. You can find me on LinkedIn with that. I use that. Those are my 2 main social platforms. So plus, of course, you can just email me, which I know is very old school, but that works out. But you don't have to email me with a specific like application security question. If you like Jennifer had the using you know, I forgot what it was, but the network tools piece, I can get you to the right person because I've got a foot in both camps now. You know, I'm a foot in the developer camp, foot in the security camp. So I know a bunch of people on the security side, and I can get you to the right person. So even if it's like, hey, so my kid's playing Roblox and I'm not sure about this, shoot me a note and I'll get you some help. But other than that, thank you all for having me. I'm sorry we couldn't meet in person and have pizza and beer and stuff. That would have been great.
Yeah. Thank you, Bill. Thank you for doing the talk today.